Hi, everybody. Sebastian here from Statice. Very happy to be talking to you about the business benefits of privacy preserving synthetic data, which sounds a little bit like how you say a title that could mean a lot of different things. I'm actually going to be focusing on a very particular topic, which is the use of synthetic data for anonymization, meaning for the ability to actually protect sensitive information in sensitive data. Before I start, a quick background to myself and Statice, company I'm representing as well. We're a German company focused on privacy preservation, data anonymization, and data protection. We're operating again out of Berlin, Germany right now, and have a few interesting use cases and a few also interesting ideas and examples around the use of synthetic data that I'd like to showcase and explore a little further. Now, we've obviously talked and heard a lot about the use of data, especially sensitive and customer data today. And the general idea overall, of course, is that user data, customer data, even patient data is very much at the core of the ongoing digitization of companies and businesses. It's a great resource to provide improved services, customer experience, as well as absolutely new, very personalized products and experiences to users and customers, which obviously is a great thing. And I think there's a lot of exciting use cases, applications for the using and leveraging customer data. But obviously, the reality often looks a lot quite different. When we talk to our customers and partners we work with, we realize that the ability to leverage and use sensitive data is far from as fluent as we would expect it to be. The reality looks like this. The reality is that data in general is not accessible for users, even internal to an organization that collects the data in the first place, due to very complex governance and compliance processes. Customer consent for the ability to use data for exploration, for example, it's basically not feasible. And additionally, this also leads to the problem that quite often companies that we interact with are unable to actually share production or sensitive data with, for example, cloud providers in order to use scalable infrastructures, which at this point is just basically absolutely not doable due to the sensitivity and therefore, of course, the attributed compliance aspects to be considered when using such data. And the question that we are considerably facing and always seeing when we also talk to organizations globally on the use of sensitive data is how is it possible to benefit from customer data in the way as presented earlier, to allowing to really build services and applications in the way that these could be very meaningful and great for the existing user base while still preserving customers' privacy. And this is the main question I'd like to focus on during today, in talking a little about the several different approaches towards protecting privacy, and then leading up to the idea of what can be done to actually really protect customer data and still keeping it in a meaningful manner for further analysis and exploration. Now, we've seen a lot of examples in the past where companies seemingly protected sensitive data, with these right now only being a few. But we also see that the idea of data protection is not as trivial as one might think. Because the reason is that data itself has so many unique attributes and unique characteristics to be considered in their entirety when it comes to protecting and anonymizing data. So if we look at a typical data set, and right now I'm showing a very public available data set with health information on individual patients, we obviously can see that there's almost always a direct identifier available in the set that will link this data to a direct person. In this case, right now, we're obviously looking at a phone number. So what we're seeing here is that there's always this ability to usually have an ID, which can be a customer ID, it can be an email address, a phone number, a name, obviously, that are able to be linked to an actual individual person and therefore identify data quite easily. Now, this obviously has already been shown in the now infamous case of Cambridge Analytica, where it was able to use user information attributed via IDs of over 50 million people to, as we're all familiar with, influence political campaigns or actually build algorithms that were able to predict user behavior properly, quite accurately, and therefore also, of course, they recommend certain content to be shown to such people. And obviously, while technically this is an exciting opportunity, of course, ethically and ethically as well as legally, very, very doubtful. And this brings us to obviously regulations such as the GDPR, with cases in the past that already shown that the use or misuse of sensitive data can have very severe impacts on not just companies, obviously, but on global democracies, as well as the actual freedom and sovereignty of individuals. And for example, in the GDPR, there is one line that clearly outlines how companies would be able to use sensitive data in a way that does not need them to go through very difficult compliance protocols. For example, when they would want to use data right now, or when a company wants to use sensitive data right now, usually what has to happen is that there needs to be a processing reason attributed to such data, which can be most famously customer consent, but also other potential reasons such as legitimate interest of a company and a few others. Now, this is usually quite difficult to argue for and quite difficult to obtain. And in this case, what we provide and what we support customers in. One second, I'll be straight back. Apparently, we're having some connectivity issues. All right, seems like we had some issues with the connection. Now we're back. So, as I was saying, there are several different reasons for companies to process sensitive user data. Now, usually this is quite difficult to manage and quite difficult to enable in the real world. So this is why, according to GDPR, there's one very direct way of using data that might be sensitive in a free and exploitative manner, which is the anonymization of data. Now, what is anonymization of data? Anonymization of data means the ability to change a data set to an extent that it does not allow for the re-identification of an individual even with very significant effort. Now, while this might be easy to imagine, the reality is often quite different again, that this is rather difficult to obtain. If we take the same example we just showed earlier, there are certain methods that are quite known to aggregate data sets in order to also obfuscate such called quasi-identifiers, so indirect attributes such as seen here in race, birth date, sex, or zip code, to link back to actual individual people. Reason being that even with these quasi-identifiers, it's quite easy by just having a certain combination of information researchers went ahead and had a look at a publicly available medical data set. And by just linking this publicly available medical data set based on the attributes of a zip code, the birth date, and the gender of a person within publicly available voters list, they were actually able to identify most of the individuals in this medical data without having the names, address, or other information in the medical data available. But just by connecting these two sets based on these three attributes, they were easily able to link information directly to a public voters list. And all of a sudden, sensitive information which were seemingly anonymous and seemingly protected were easily linked to a person, and therefore, of course, exposed very sensitive information that ideally nobody wants to have publicly available. And that brings us to the typical problem of data in itself, that even if there's no direct or even considerably indirect attributions, quasi-identifiers present in a set of data, information that might seem very ordinary can, in a very big quantity itself, serves as a fingerprint. So, for example, if we have information here on the headache tracking, it's possible to just, by having enough data points on headache, use this information as a sort of fingerprint and link this back to an actual individual person. There's been a case study or recently released that shows that in car systems, it takes about just 15 minutes of braking patterns to uniquely identify the driver. And this gives you an idea of how information that itself seems not to be relevant and sensitive at all, just having enough of it already provides the ability to link very sensitive information to a direct person by providing serving as such a fingerprint. A very strong example here that's also quite well known is where researchers went ahead and used a publicly available data set that Netflix released for a data science competition about more than 10 years ago. And looking at this set of data, which seemingly was anonymous again, were able to, by just looking at movie ratings of individuals and link this with data from the IMDb, a publicly available database as well, just by looking at 4 to 5 movie ratings a person, they were able to link entries from the Netflix data to a publicly available profile of a person in the IMDb, and again were able to identify over 80% of the individuals by just looking at a sequence of movie ratings. And again, this gives you the idea similar to how data should not be, that seemingly is protected, really isn't. Now, we talked about data protection and privacy, and obviously there's also a different aspect to compliance. If we, for example, look at the example of Strava, a running app that released data on geolocation traces of their users, what was interesting to see that while there were very beautiful pictures of running tracks available in this data, it also accidentally revealed very sensitive information on stuff that ideally was not supposed to be revealed. For example, here in the Saharan area in Africa, running tracks in a very peculiar pattern on a small area actually revealed the presence of a secret military base that was not supposed to obviously be leaked by such a data set. So next to data protection for a privacy concern, we also have the issue that data itself, while not being directly linked to a certain entity, might reveal in a certain way very sensitive information that should be kept compliant. Now, the problems here, or the takeaways we see here, is that first of all, the pseudonymization, meaning the scratching or the deletion of information such as an ID, an email, or direct identification is not enough to protect data. And on the other side, even if you go ahead and start aggregating data or changing data on some parts, but leave other parts of the data set untouched, this untouched part of the data can still link back to real individuals as it considers or contains data that in itself serves as a fingerprint. And it's important, therefore, to not assume that you know what information in a set of data is relevant, needs to protect it, and what information in the data set is not sensitive and therefore does not need to be protected, as it only takes a specific amount of information points that itself serve as a fingerprint and can therefore be linked back to an actual individual or sensitive entity. Now, this also means that if we take anonymization very literally, we technically would have to go and just scratch out information in a set of data, because somehow everything can link to a real person or entity that needs to be protected. Considered okay, tend to also coincide with the loss of a lot of data utility and granularity. And therefore, we have this problem that we continuously deal with a trade-off between data privacy on the one side and data utility on the other side, something that ideally should not be the case. And is this something where, of course, the question comes around, like, is it even possible to protect data properly while still preserving a strong aspect of its original statistical relevance and values in order for it to be processed further? And one ability of the granularity of an original data set. So a methodology that we focus on quite significantly at Statice is the idea to use so-called deep generative models and the concept of differential privacy in combination to train models in a privacy-preserving manner, picking up statistical relevant information in an original source of data and using this to generate a new set of data that we consider, again, sort of synthetic data, that itself has no one-to-one relationship to the original data, but still preserves the overall structural and statistical properties. Now, differential privacy itself is a very exciting mechanism. I'm not going to go into too much detail, but the general idea is that it's basically a mathematical definition that, if fulfilled, ensures us that in a query asked to a certain data set, as well as to a copy of this data set minus one entry, results in roughly the same probability of the same result, which allows us to infer that, or which doesn't allow us to infer certain information of an individual being or not being in this in either data set. But again, I'm not going into too much detail here, but it's a quite exciting concept to look further into. And it has the following advantages. It allows us to, first of all, make sure that we don't have to have any assumptions about an attack scenario, provides a formal theoretical definition on anonymity, and it allows us also to not having to worry about, computational complexity or computational heavy attacks due to a very robust guarantee in privacy. So what does this look like? Now, while we saw earlier that anonymization methodologies that are more traditional tend to change a set of data, what we do here is, again, have a generative model that trained or is trained on the source original data, which we see in top, and picks up statistical properties and uses this to generate a new set of data that we'll be looking at the bottom. Now, these are only 5 entries out of a larger data set, but what we tend to see, which is quite exciting, that if we compare the top original data and the bottom the synthetic data, trends are picked up almost perfectly in allowing us to compare several different statistical tests on both data sets, resulting in almost the same output. Now, this allows us to, use or provide a method of anonymity or anonymization that, again, combines the concepts of privacy and utility at the same time. And I'm going to skip to these parts because that's not entirely relevant right now. But what is exciting are actually the use cases that are possible on such privacy-preserving synthetic data. Because where beforehand data was generally not applicable and not available, and where people within corporate entities or even between partners had to go through quite complex compliance and governance processes, they're now able to use data that mimics the original data in an almost perfect way without having to go through these kind of processes, without having to wait for access, and use it for quite a variety of different applications such as statistical evaluations, BI analyses, but also the training of machine learning algorithms where prior there was no data to do so. And the ability to do this, of course, then results in the idea of having quick and improved development efficiencies for the use of data, the potential to opening up new revenue streams for companies, but of course also to ensure compliance along the whole data value chain from where the synthetic data is used for further analyses. So this was an overview of the methodology of synthetic data, which ideally in our perspective serves as a very good alternative and a very viable alternative to traditional approaches to anonymization, because it actually combines the ability of protecting data on the one side, but also ensuring the use of still statistical relevant information on the other side. Thank you very much.